Welcome to the module 4 of industrial automation and robotics. So in the module 4 we are going to discuss about the spatial description and transformation position. The spatial description and transformation here it is very important when we design the robotic structure. So here kinematic transformation and the space what you are going to utilize, it is very much important, and how you transfer the information from different links and different joints present in the robot. So reference is taken for all types of robots we are going to design. So mapping can be done by changing the description from frame to frame, so that you'll be able to set the position. And the position orientation and frames has to be calculated by framing the matrices. So different operations what we're going to translate, different operations what we can run by using the robot is translation, rotation and transformations. So further transformation arithmetic and transfer equations are used. So further we are going to discuss about the orientation, transformation and flay vectors. So what is this position, orientation and flay vector? We are going to see step by step. So here position vector it is shown by 3 by 1 matrix. So here in the position, that is, if you take A position with respect to point P, AP it is shown at 1 point. So here in the vector is shown that line AP. So it is given by with respect to point P, X, Y, Z positions it has been shown. And the orientation, it is A slash P, it is as shown in the figure. In the next figure it is shown about the orientation. So here orientation, here we have shown the figure 2. So the robot it has got this point, means from that point we are going to calculate the different positions. So from A to B, how the motions are going to happen. So here the rotation matrix is formed. So 3 by 3 matrix it is formed of the vector. So further if we calculate with the A with respect to point B, so X, Y, Z orientations with respect to A, B point it is considered. So as the motion happens from A to B, all the necessary points are considered for calculation. So like this frame of description of A to B frame, what all the possibilities are there. So in terms of the row matrix, and it is also a unit vector which it is going to be framed, here it is shown. So further we will discuss about how frame is framed. So frame, here you can see what is a frame. So here the position and orientation pair arises so often in robotics that we define an entity called frame. So here you can see based on the point the frame gets shifted to the different positions. So there the axis keeps on shifting so that the required motion is achieved. So here representation of frame, here it is shown in the graphic sense. So here you can see initially the robot is at one point. Initially the robot is at one point, it has to move to the different positions. So like this the required points are kept in the position. So here X, Y, Z with respect to point C, X, Y, Z with respect to point B, X, Y, Z with respect to point A. So like this different frames have been done. So here it is maybe in the forward location as well as the reverse location you are going to place the required frame. So how further from frame to frame changes it is going to happen. So here mapping involves translated framing. So here we keep on translating the position from one place to other place. So here vectors are defined related to the frames of the same orientation. The description of the point P relative to A, it is indicated as AP by vector addition. So AP is equal to BP of A, B, PB, ORG. So with respect to origin, it is done like this. Simple mapping is carried.